Hello, everybody. Welcome to my video again today after a long break. And today we will be talking about how to perform multiple linear regression with R. You want to perform a linear regression, but this time it's going to be a multiple linear regression. Sometimes a lot of people are very confused about what to compare with another thing. So this would cause a lot of problems for them when they arrange this data. But today I would use the Jupyter Notebook with my R, which is something I really cherish a lot because you can write your codes for a cell. You can easily delete it. So I will start with I would not do much with uploading data wherever. I would use the data which is already embedded in R. And this is going to be the empty cars data, the empty cars. So I would write the empty cars and I would run it. So this is the empty cars data. If you want to know more about this data, you can just write a question mark and you can write a question mark and empty cars. So when you run this data, it's going to give you more information about the car. Because I want to make the video very short, I would not be saying much about all the data and what it entails, but I would tell you the information about it. The MPG stands for the miles per gallon that is in the United States. The CYL stands for the number of cylinders. That this stands for the displacement. The gross horsepower is HP. So you can go and check more about the data yourself. But what I'm only after today is the topic, the multiple linear regression. So let's quickly double into it. So the first thing we do is you try to get very little, like just 5 or 6 lines of the data. So how do you do that? You want to view the first, let's say the first 5. You want to view the first 5 lines of your data, of the data empty cars. So how do you do this? So it's pretty easy. Just write a head, keyword, and empty cars. Close the parentheses. You click on Command Enter, or you click on this play button. So they both work for it. So we've got Mazda RX4, the MPG is 21, the CYL is 6, the disk is 160, and you can see all the data there. These are the variables, and these are the type of the cars which have been used for these experiment, this data analysis. So after you've been able to do this, we want to build what we call a multiple linear regression model. So we're going to build a model, and we use the model with the MPG. So we want to give a response to variable and displacement. Also, we want to use the HP. We want to use the, so I would try to use the displacement. I will use the HP horsepower. Then I would like to use the DRT, DRAT, and I will use these as a predictor for my variable. When we mean we want to make something a predictor for the variable, that is to say, I want to focus on this and I want to use that. I want to deal with all of these variables as a predictor for my multiple linear regression. So my multiple linear regression will be acting based on these variables. So I would, so what do I do now? I would create a new data. This is something unique about R. It's easy to create new data from a whole bunch of data. So it contains only only the variables I want to deal with, the variables we would like to use. So what are the variables I would like to use? I want to use, let's say, data. So I'm creating a variable called data, and I'm trying to draft out some data from the bunch of data, a bunch of information we have. So what do I want to do? I want to create a vector for this data we want to deal with. So what are these? One of them is MPG data. So I put a comma, then displacement, then I put a comma, then HP, then DRAT. So if you go up, you're gonna see more information about them. So the DRAT means the rear axle ratio. The HP means gross horsepower. This means displacement. This is the number of cylinders. And this is the mile per gallon in the US. So now we've got the four variables we want to deal with in this project. Then you're gonna just make. So now we've got this. So we want to, if you click on run or you use the command enter, so it's run successfully, meaning there is no problem with slicing the data. So what do? We want to view. I'm trying to do all these things for, in case you want to go back to the video, you're going to know exactly what I did. The 6 rows. I would encourage you to listen first and not try to write the codes after me. If you understand the concept, you can actually do them back again yourself. So of new data frame. So new data frame. So let's check them out. Let's check the new data frame out. So add data. So then you click on command enter. So now we've got only the 4 variables we wanted to have. If you want to check more, you can do that. It depends on whatever you think about. So it's giving us everything we want to know about the data. So what else do we need to do? We want to examine the data itself. So there is something called fitting. So we want to examine the data before we fit the data. So fitting, we can examine the data to gain a better understanding or a better knowledge of the data. And also we can visually give an assessment to the data whether or not multiple linear regression could be a good model to fit this data, because sometimes we want to use a model and the model is not going to fit the data properly. So we need to take some time to view the data ourselves and see if what we want to do with it is going to work out. So we need to check the predictor variables. If they have what we call a linear association, do they actually have a correlation? So we need to check that with the response variable. So we also need to check what would indicate that a multiple linear regression might be suitable for it. So all of these things are things we need to do. So to do this, what do we need to do? We're going to use what we call a pair function. So the pair function will help to create a scatter plot. So the scatter plot will give us a kind of brief understanding of every variable we actually selected. So now what do? We write the we use use a pair variable, pair function, sorry, to function to create a scatter plot of every possible pairs on the variable, every possible pairs of the variables. So the 4 variables we're using, we want to create. So let's write a code. You write pairs function, then you write data. Then in the data, you write a PCH is equals to 18. So, and you want a color to be the steel blue. You can use any, you can use a red, whatever you want. You can use red. So you can use a dark red. Let's use red. So then you close the parentheses. So let's run this if it's gonna work. So now we can say. So this is the data. So we've seen the MPG, we've seen the displacement, we've seen the HP, and we've seen the RT. So from these pair plot, we can see that the MPG and the displacement appear to have a strong negative linear correlation. So what does that word mean? The word means that when MPG increases, the displacement decreases. So this is what we call a negative linear correlation. So, but MPG and HP, they appear to have a strong strong positive linear correlation. So we can see from the data, like this, the correlation here is almost the same as here. And the correlation here is something similar. So than this, because this is not going the same way at all. When this goes this way, this goes this way. When this goes this way, this goes this way. So it's not correlating with each other. But what about the MPG and the drought? They appear also to have a modest negative linear regression. So the MPG and the drought do not actually seem to appear to have a good correlation, but at least they have kind of a similar bit negative, but not that crazy, like you have for the MPG and the displacement. So now we would also do the GGPS function for the G-Galley. There's something we call in the library called the G-Galley library. We want to use that to create a similar plot that contains the actual linear correlation coefficients for each pairs of the variables. So this is something which are the very good things we do in the beginning to check if it's going to be proper for us to work with the data we want to work with. Otherwise, we're going to switch quickly before we start wasting time running things, which is not going to give a good result. So we call it's called G Galley, LY library. So how do you do that? We install it. Install the packages. So this is the difference between the Jupyter Notebook and the RStudio. So the RStudio would bring out the names completely for you once you start typing things. But as for this, you're gonna have to do all of it yourself from the scratch. So now we're trying to install the G Galley. So let's install it and see. So after installing it, if everything seems fine, let's call the library. So let's call the library. Okay. Still busy installing it. So G. So also installing the label from, so it's installing some other dependencies. So this is very good. So now we'll make it easy for us to have all we need to have time. So we're on the library, then we want to generate, after that, we generate the pairs. We generate the pairs plot. So then we will call the GG pairs then into the name of our data. So let's run this and we'll take a break. So let's run this. So if it's not running fast, that means it was still wow, that was pretty fast. So we've got the data, we've got the data set, we've got the visualization already. So from the visualization here, we can see that each of these predictors variables appear to have a noticeable linear correlation with the response variable MPG. So they will have something similar. So we will proceed to fit the linear regression model to the data. So this is going to be amazing.